So hello everybody and welcome to today's webinar CI/CD Part 2. This webinar will be presented by Ruben Draw and we will open up for a live Q&A at the end. So enjoy the webinar and over to you, Ruben.
Thank you, Emily. Hello everyone. Welcome back to the next episode of our OpenEdge TechTalk series. As mentioned by Emily, today's talk is called CI/CD Part 2 and is obviously the sequel to an earlier CI/CD talk I did about 3 months ago. Well, you know what they say about sequels. Let's hope it gives you at least the same information and let's say more than you got out of the session last time around. And though I will include a small recap today of what I've discussed in the first session, it might make sense to watch that talk first before jumping into this one, because obviously I'm not going to repeat everything I've said there. And the same probably goes for my tech talk on containerization, since I will be using Docker today to deploy an application. Yeah, all of our OpenEdge Tech Talks are recorded and are posted on our website. If you just Google on OpenEdge Tech Talk, then you will be able to find it. Like Emily mentioned, my name is Ruben Dreuge. I am a solution engineer working for Progress for almost 6 years now, and I work from the Rotterdam office. Okay. So let's have a quick look at the agenda for today. Of course, I'll start out with a quick CI/CD recap of what we did in the first session. Then we'll discuss my tools of choice. Obviously, it's debatable. There are a lot of tools out there that can help you setting up a CI/CD pipeline, cloud products, on-premise products, you name it, everything is there. I'll just discuss my choices briefly and continue. Then we'll talk a little bit more about building, packaging, and deployment, because that's actually the part, especially the packaging and deployment part, is what we didn't cover in the first session. And obviously, I'll show you a demo again with the packaging and deployment of my application. After that, we have room for questions. If you have any questions during this presentation or this webinar, just put them in the question box and I'll make sure that I'll either answer them then or I'll answer them afterwards and I'll contact you. And finally, I'll end up with some references that you can use probably to set up your own CI/CD part. Okay. So what and why CI/CD, and a recap, what we already discussed. I think the definition is always useful to look at it again. So continuous integration is a coding philosophy and set of practices that drive development teams to implement small changes and checking code to version control repositories frequently. Because most modern applications require developing code in different platforms and tools, the team does need a mechanism to integrate and validate its changes. The technical goal of CI is to establish a consistent and automated way to build, package, and test applications. And with consistency in the integration process in place, teams are more likely to commit code changes more frequently, which obviously leads to better collaboration and software quality. There are 2 terms for the CD terminology in CI/CD, which is continuous deployment and continuous delivery, where with delivery you offer basically deliverables that can be used later on, and with deployment you actually deploy your application or deploy your changes to a staging production environment, etc. So just a quick plan here. So we've got, obviously there's a planning phase in there, there's a coding phase in there, there's a building in there, there's the testing phase, but then there's also the release, deploy, and operate phase. So in terms of operating phase, that would be a next thing there, which is very much, well, if you're going to use containers to deploy things, it's very much Kubernetes or Docker Swarm or micro-K8s related. That will be for another time. This is first just mainly about packaging and deploying it to a Docker container. Well, all the advantages are quite obvious. If you do this correctly, it will save you time, it will save you money. Okay, quick demo recap of the things we did last time around, which I actually showed. Basically coming in from a check-in of a change in your source control management system. I'm using PDSOE, eGit, GitLab for that. Then we had some scripts to build, compile. Obviously, there was all AND and PCT. Then there was code quality checks involved as well. That's all done by SonarQube and Sonar Scanner. And to glue this all together, we used a build automation tool, and in my case, I use Jenkins to do so. Okay, so the tools of choice for today is actually, like I mentioned before, it's arbitrary. There are a lot of good solutions out there, but I'm using GitLab for version control, using Jenkins for build automation, using AND for packaging and scripting, ABL unit for unit testing, Docker for containerization, and SonarQube for code quality, like I mentioned before. The whole packaging mechanism that is what I'm going to show today is also based on AND scripts and PCT. To come back to all this, I think if you look at the questions that I got after the last session was, could you do the same, you know, all within GitLab or all within Azure kind of solutions that are out there? Yes, you can. There's nothing that prohibits you from using another solution. GitLab offers pipelines out of the box as well, so does GitHub, and so do probably other providers do as well. So it's just, you know, you mostly choose the toy you like or already used before. Makes it easier to get started. Okay, so the full flow here, also based on the work we already did in part 1 of the series, is what we call in defining the pipeline. So again, there's a checkout of sources from your source control. There's a compilation of sources, so you have to compile everything. You probably need to execute some tests, being in this case ABL unit tests. You're going to execute code quality metrics using SonarQube and Sonar Scanner. But then we get to a point where we say, okay, so everything looks good basically. What's next? You know, we want to package this thing into something that we can actually deploy, so a deployable artifact. Today we're going to use something called the ABL WebEx package, which is also an AND script that we offer, which makes it very easy basically from a project perspective or source project perspective to build your web app that you can then deploy into a Docker container, into our base image that we offer as well on ESD and on Docker Hub. You can deploy everything onto there and it runs straight up from there. So that's also mainly the next step then is to build that container image, deploy the artifacts there, and get it started and make it actually work. Okay, so for the demo today, we're going to package for deployment, which is again a combination of AND and PCT, and for automation purposes, we use Jenkins. And we're going to actually deploy it. And again, we're using Docker for that and Jenkins. Okay, so let me get to the point where I can show you some things. So you've seen this project earlier. This is my generic service project, which I have in GitLab. As you can see, everything is in there. And the new things that were actually introduced were a few folders that you can check into your source management as well. A Tailor folder, which has some properties that will be merged when deploying. Make sure is that our ABL application uses a certain startup to connect to the database in this case, but you could have a few other software in there as well. And we've got a config folder which actually contains that startup TF, which contains, again, a connection to my database running on one of my virtual machines. So for the purpose of simplicity, I'm only going to use the PESOE container base image that we have. We nowadays also have the container for our database for this purpose actually. But you know, I have this database running on my machine already, so I just thought let's skip it for this part. But it's basically the same mechanism that you'll be using. One thing is that I forgot to check into my source management system. It's the services file, or services folder, I should say. This needs to be added as well because the end script will use information from this to actually create the ADL web app package that we can later on deploy. So that's the first part. Obviously, there's source code involved here. And at the end of the day, this is an API which will give you a sort of a more normal REST API than the, for example, JSDO implementation. So we should be able to test it at the end and see whether we can actually use that API running in the container. So this is from a source code perspective. Obviously, again, we have the build XMLs here, which Ant uses for its build. We also have one in the PESOE content folder. You can add some build properties in here. So if you have a different structure or you have a project name that you want to use in the eventual zip file or WAR file that we're going to create or generate, you can change it here. Basically, you make it whatever you want to. Okay, so from our source content management, we come into Jenkins, our build automation tool. And this, some of you remember, was the task that we already had last time around, which contains a few steps. It supposedly fills every time, but to be quite honest, it doesn't. But it has to do with the fact is that my license for SonarQube has expired, so that's why it fills at the end. Going to use OpenJDK 11. It's also changed because I'm doing everything on OpenEdge version 12.2.1, and 12.2 has only support for Java 11. So that was required to change that around as well. We've got our link to our source management system. So whenever there's a check-in, this task will basically change. It will actually fire and go on. And there is this very simple end script that I'm calling here, and there was one target in my end script, I should say, which is so-called package. So if we go back, we can basically see if we go to the generic service build XML, we expect something called package in there. And there it is. There is a target name package, and it depends on clean and compile. So it will basically do all of that when it needs to create the package anyway. So what does it actually do? This one actually builds sort of the ABL app package, but it needs the web app package as well. So it's a combination of both that we're going to deploy, and it's going to be put into one zip file, which includes both all of the web apps that belong to the ABL app, and obviously, in this case, also the compiled R code. And folders that I said earlier. It's the Tailor folder and the config folder. So if we have a look at the build XML file in the PESOE content folder, there you'll find is that we're actually going to create that web app. So the WAR file for the web apps. And that's the ABL web app package that I was talking about earlier, which is documented as well. As you can see here, there's a document saying, so what is the stuff that I can do using the ABL web app package task? You just need destinations there, web app names is incremental, and those kind of things. Obviously verbose for more logging. Okay, so that is basically what this thing is doing. Then it has all the Sonar stuff that I showed you last time around as well. So that's one task, and that's a task basically that we already set up. I changed it a little bit around because we're now doing the web packaging, obviously. But there's also a second part to this. And this task or this project will actually fire whenever the OpenEdge project is fired. So let's have a look at this one. So what we're doing here again is just a simple AND, another AND script basically that I'm using, and I'm using here the thing called deploy. And I need to show you where this is actually located. So all of the deploy scripts we actually offer as part of our Docker base image, which is downloadable from ESD. So if you download our base image for both database and PESOE from ESD, it will include the deployment scripts, which is obviously a good thing. Let me quickly browse to the part where I have my deployment stuff. So I have two workspaces here, basically our OpenEdge workspace. This is what Jenkins uses basically to do all of its temporary operations. And we have a Docker image folder. So basically this structure is something that I got directly from that download from ESD. It's also documented in a community article. It's using the container image for patch for OpenEdge 12.2 with a sample application. If you download these, so there's the sample app, but there's also a link here to the deployment scripts, which make it very easy basically to implement this in your own CI/CD pipeline. Just read it basically and then just implement it, and you can reuse like 80–90% depending on some of the choices you might make. I encountered, for example, I wanted to do a little bit with microcage, which is sort of a simplified version of Kubernetes and a way to create and start containers, and orchestrate containers. And we do offer some deployment methods out of the box. So that's, for example, Docker, but also Docker Compose. And we also have a mini Kubernetes that is supported. But my flavor wasn't in there, so basically I decided just to go the Docker way. So let's get back to that deployment script, so the AND task. There we go. So if we look here, I'm using a deployment method for Docker. So if we look at that build script, there's a lot of things happening here. So the way we're deploying here, it uses what we call a sidecar container that has JDK in there, so Java, that's running in a separate container basically, which is also always started on starting this container. It's also starting the Java JDK Docker container. So that's very good. We're doing a lot of deploying here. So there's obviously some stuff in folders that I mentioned earlier. So we've got this artifacts folder. We've got a We got a license folder, so you need a valid license to be able to run the PESOE at some point. So this is just a license file that I created, and I put it in the license folder here. And later on, during the whole build, basically, it picks up that license, puts it in the container, and makes sure that it can run like that. So that is if you choose the Docker build model, load or deployment model, I should say. As you can see here, I can choose the deployment mode. Could be with the Minikube, Docker Compose, or Docker. I can choose a Docker image name. I can Docker image tag, so it creates basically a Docker image for me as well, which then I can, for example, push to Docker Hub as well, and then have that ready to go container, and other people can download it from there. It's a cloud-based repository. I have a Docker image name, so I made sure that I downloaded an image for adopt OpenJDK 11 hotspot, and I need to enter the location path to the JDK inside the container, so it knows where to find Java. Well, it's pretty much default. I can decide what my PES instance name is going to be in that container. For simplifying reasons, I just chose to be OEPES1, as the default is. The PESOE Docker image name is the store progress software PESOE. So I am actually downloading this while building it from Docker Hub. Well, that's initially, so the first time around, if you don't have it yet, that image locally, it will get it from Docker Hub. You need to log in first. It's free, obviously. The only thing you need to supply is that configuration file. We've got an HTTPS port because this is the production part of the product. There is no HTTP port, so you're using the HTTPS port. And there's a choice whether you want to enable the fluent bit logging. And for that, obviously, we need to go back to the session we already had on the logging stack and containerization, which is fluent bit, Kibana, and Elastic in combination, and it gives you very flexible ways of reporting the performance of your on your containers. Okay, so that's basically this workspace is that we have here. What it will do first then is basically with the other tasks, so that's the task I mentioned before, the OpenEdge task, will create a zip file that contains the deployable artifact basically of my application, and which will be placed in the ABL apps folder, as you can see. So this is the generic service zip, and that contains both WAR files and those kind of things. So it's sorry about that. Okay, so that's one part of it. So let's see if we can get this to work. So for all of my demos here, I'm using local stuff, either Hyper-Vs. Right now I'm experimenting a lot with the Windows subsystem for Linux 2, which seems to work quite well with a few hacks here and there to get everything working, especially for things like microcage. To get that installed, you need to hack around a little bit, but it gives me, at the end, it gives me much more flexibility, especially since your file system is very easy to reach because it's just another Windows file share, those kind of things. So it makes it a little easier. So let's see which containers are actually running at the moment. As you can see, I have SonarQube running, I have my Jenkins, which is up and running, and the other two are just basically containers that are in a stop state or created state, which are not running at the moment. So that's good. So I don't have to start anything right now, which actually saves time. This is where we're actually going to see whether we can test that API that will be running inside the container. But maybe we should just kick off the task first the OpenEdge task and see what happens there. And as it progresses, we can basically check the console, what's actually happening. So like mentioned before, first, we're wiping out our workspace so that everything is clean. We're getting our sources from our source control. Then we're actually starting to build here. And we're doing a clean again of the output folders, build outputs, those kind of things. We're compiling everything. We're compiling this one as well. And this is the single file is the web handler class, basically. So actually that what defines the API. Another clean. And then we're going to start the package. And I put on the verbose option because I wanted a little bit more information what it's actually doing. Now, as you can see, it sees whether it's checking whether it has REST services, and it's also checking web speed services. And actually, web speed services in this case are my web handler things. It copies some extra files, it generates the handler file, and eventually it creates a warrant file. So it puts it in a temporary file because you need to name it a little bit different because you're going to add the R code to it afterwards and then rename it basically to, well, in my case, OpenEdge.war because my workspace is called OpenEdge, but you can pull in everything you want. And then finally, we're building the zip file. So this generic service.zip. And it will continue afterwards with everything Sonar related. And then we get to the point where, oh yeah, unfortunately, my license has expired. So this is why it says it's filled. It actually didn't. Now we're having a look. And as you can see, it also said it executed my Docker image task on my project. And that was actually a success. So let's see what that actually showed from a console output. Again, so we're going to clean, we're creating the instance zip. So that's basically the zip of the OEPAS1. We're checking some required files, but then basically it starts all and it will get everything into the doc image. And I call this docker -test-PASOE TechTalks. And that will run. And then basically we're going to the deploy phase. We also have the part where the Java part is actually added. And as it finishes, it says the PASOE instance named PASOE instance _d will be available at blah, blah, blah. Well, obviously, I have my IP settings set up a little bit different here and there. So let's see if it's already there. And as you can see, it's already there. And to be able to show you that it's actually coming from the container running on my system. We should check again what the list of containers is. And there it is. So it actually uses, as you can see, that name. So it's store progress software PASOE. So that's a base image that we're using. And it's called, we gave it a name, and that's OEPAS1 PASOE instance D. So that's basically the name of your container. This is the image name of the container. And this is actually some of the commands that are executed whenever you start the container. So that is basically very short the way of doing this. And as you can see, change this, for example, and actually it all works just like it's supposed to do. It's fast, it's spun up, and I haven't optimized it. There are some tricks to optimize your the speed with which your container actually starts up, because now I think on my laptop it takes about 40 seconds to be up and running, which I kind of dodged now because I was talking and showing some of the things in Jenkins. But there are some tricks to tweak the performance of starting your container. And obviously, the nice thing about containers is when you're done with them, you can basically go and just say, let's first see which containers I have. I'll pick this one. And I'll just give it a docker kill command, boom, and it's gone. Just like that. That's how easy it is. So our API should not be reachable anymore, and it isn't. So let's get back to this one. So as I can show you today, we packaged for deployment using the ABL web app package and task that we have available. And we deployed it actually to a Docker container. And also using the end script, so that we offer as well for the deployment of your application. So then, what would be the next steps? Obviously, that would be a deployment to a production scenario. But then you're getting straight into the orchestration of containers as well, which is very important in this case. Why? Because microcage or Kubernetes or Docker Swarm, for that matter, well, one of the main advantages is that you can scale out so easily. It's just like you're just saying, I want 3 or 4 replicas of the same container, and it will spun that up for you. But it also offers container management or replace features that helps you very easy to deploy newer versions of your container images without taking everything down, basically just replacing them one at a time, so that well, you achieve a high available scenario. And then again, also combining it with stuff we did earlier with the container logging, using the EFK stack to combine it as well. I already see a question because we're at the question part anyway. The half hour has passed already. One of the questions is it possible to get the demo project in order to follow the configuration steps? So yes, I think this demo project is a public project in GitLab. I will check it just to be sure, and I will make sure is that it's shared within the contents that we're sharing anyway as well. The link to it. I am in the process of writing up every single thing that I've done since I've started this project, which is quite some months ago. It's a lot of work, you know, I have to do it in between, but I am writing it up and I will post that. We'll probably end up somewhere in communities with all the steps basically that I had to perform. And I have to see how deep I will get into some of the installation stuff, because especially if you're going to run everything containerized, so Jenkins is running as a container as well, SonarQube is, well, Elastic, Kibana, name it, everything runs in containers. And the cool thing actually here is that you can trick it a little bit so that Jenkins from a container, the running in a container, is actually spinning up containers on the host that it's running on. So it actually has access to the daemon of Docker on your host system, which is in a real life scenario probably not something that I would prefer, because there's a little bit of permissions involved, and if you have access to the host, then basically Jenkins can do a lot that you might not want it to have. So there are some things that I have to think for myself the way I'm going to write it down. So I did start, and I will publish it as soon as a part of it has finished. Another question here is, are there tools to create the license file without installing the products? So I think in the customer self-service portal, we nowadays have functionality to create this type of file. Apart from that, no, I don't think there is one. So to be quite honest, and to answer your question, what did I do? Yes, I already had an installed version of OpenEdge 12.2 on Linux, basically, and I just copied the file and put it in there. that's for now was for me the easiest way, and I think there is a functionality in the customer self-service portal, but I will make sure is that I'll check that whether it actually functions as designed. But it's, yeah, for obvious reasons, it's more difficult for me to test it than for you guys. Some of the references, I already showed you 2 links. So either you search the community and look for the document on PESOE and Docker and 12.2. That will help you a lot. Obviously, these are the very generic links, and I will work on a more, let's say, step-by-step approach. Okay, so I have another question, so bear with me. What's the suggested Windows Server platform for the Docker installation? I've had problems with the Windows Server 2019. And yes, I agree that Linux is a better deployment platform. That's an interesting one. So it depends a little bit on what it is that you mean in this case, because so as you know, we do not officially support Windows Docker containers or Docker containers on Windows. We only support them on Linux. Having said that, so that's first the thing that needs to be solved anyway, to make it possible to run Windows containers. There is already a suggestion in AHA, so our OpenEdge ID section, that you can vote on to make, well, to get attention from product management, that they can start working on certifying Windows containers as well. And with the direction Windows is going, and this is sort of my own opinion, obviously, but with the Windows subsystem for Linux rolling out in Windows 10, and it's getting better and better, well, you could get to a point where it's basically possible also within your Windows Server installs to actually run Linux containers within Windows. So that would be interesting as well. But you know, I can look into the future. If you want Windows container support, vote on the ID. It already exists. I checked it like last week, so it is there. And to point you out to you, we have at least one next session planned. It's October 1st. That's a session which is all about resilience and security. So hope to see you there. So if you have any questions, suggestions about topics, about content, those kind of things, please let me know. You can find my email address there. Yeah, Wim, hope to see you also presenting on the virtual EMEA PAC challenge. We're working on that. So yeah, I really want to tie everything together at a certain point. You know, these are sessions of 30 minutes, so you can only tell as much in 30 minutes. But it would be cool, you know, to get everything together from start to finish, basically, and then also combine that with a actual operating application with Kubernetes or microcades to make sure it's also high available and you can deploy on the fly, basically, without taking your application down.